Okay, the trapezoid rule. The trapezoid rule is a method of solving integrals when the antiderivative cannot be found. It uses trapezoids instead of rectangles to calculate the area. Much more accurate than using rectangles. Trapezoid's going to follow the curve a lot more closely than a rectangle would. Now, you can still get underestimates and overestimates, and that does deal with concavity. If you have a function that is concave down, you're going to get an underestimate because every little line going across is going to be underneath. If you have a graph that's concave up, your trapezoidal curve is going to be an overestimate because the curve is going to go underneath the points connecting the lines. Okay, so you will still get over and underestimates. The one thing you need to have down from here is that you absolutely need to know and remember the area of a trapezoid. Okay, now, when I was your age, there were no such things as graphing calculators. If you could not take the antiderivative, this was it. Okay? If you had to solve an integral of which there was no antiderivative to be found, because sometimes it's impossible to find the antiderivative. Derivatives you can always find. They may be ugly, they may be nasty, but you can always take the derivative of any function. Finding the antiderivative, on the other hand, can be extremely difficult, if not nigh on impossible. I will show you tricks to get some of the more difficult ones, but there are some you say, just screw it, I'm going with this. Okay, and this is what we had to do. You had to do something like this. Be glad you have your graphing calculators instead. Trust me, it's one of those things that, yes, I like calculators as tools for things I don't have to do anymore, and you don't either. Okay. So what we're going to do is the height, you divide it equally spaced. Each one of these is equally spaced. Now, I'm going to draw a demonstration. You do not need to have this down in your notes. Okay, but I want to show you what I'm talking about. So I have a function, f of x, and I'm going from A to B. Okay. And what I want to do is I want to find the trapezoid. I want to find the area underneath, breaking it up into trapezoids. So what you do is you just break it up, divide it into equal spaces. Okay. Each one equally spaced. And you're doing a trapezoid. Okay. So your area of this first one, this first trapezoid, it's 1/2. This is your height, your distance here, height. This is your height here. And if they're equally spaced, that's where this formula comes from. You take the distance between A and B divided by how many you have it broken up into. That gives you your width. That also tells you where to find your points of breaking apart. Okay? Now, I want to find this first trapezoid, just the area of the first one here. Area of the first one. It's 1/2 times B minus A over N, because that's what my height is. That's the width of each one. And then my two parallel sides, base 1 and base 2, are the two y lengths here. Or, in this case, f of A and f of x sub 1. But I'm not going to call it f of A. I'm going to call it f of x sub 0. So I have that times f of x sub 0 plus f of x sub 1. That's the first rectangle. Or sorry, first trapezoid. Second trapezoid, same thing. Area of the second one is 1/2 times the height, b minus a over n. N is just how many trapezoids we have. Okay, and if they're all equally spaced, h is the same. Times this side here. Ooh, f of x sub 1 plus this length here, which is f of x sub 2. And so on, and so on, and so on. And then the last one, this one right here, is going to be 1/2 b minus a over n times f of x sub n minus 1, the penultimate one, plus f of x sub n, the nth term. Okay. Question I want to ask you is, how many times is this side here used? How many times is this side here used? Twice. This one here. 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 Once. So the ones on the end are used once. Everything else is used twice. So, looking at here, this is the first one. This is the second one. This is the third one. This is the last one. If we take that, which is really nasty, would you really want to do that? No, but there is a formula. Pull out the 1/2, because it's 1/2 in every term, right? Pull out the b minus a over n. Pull that out. So that ends up being, this is 1/2 times b minus a over n. Multiply the two, you get b minus a over 2n. That's these two here multiplied out, pulled out of each term. And then what I have the first one used once, next one used twice, next one used twice, next one used twice, the second to last one used twice, the last one used once. Figure out what those f of x's are and plug them in. This you need to have down. That is your formula. That is the formula you use if you're given a function of which you cannot do by finding an antiderivative. Now, every problem I give you for the example, for your homework, and on the test are ones that you can do by finding the antiderivative. Because I'm not going to be mean to you and give you functions that you can't find the antiderivatives of, and thus are forced to use the trapezoid rule, because those functions would be very difficult to find f of x. The directions will say, use the trapezoid rule. If you use antiderivatives to solve it and do not use the trapezoid rule, you will receive 0 points for not following directions. The reason I give easy equations aren't so you can bypass my directions. They are so it's not so horribly difficult. It's going to take you forever to do the problem figuring out your f of x's. I give you f of x's that are easy to find because I'm not mean. I can be mean. And I've had students not answer it the way I tell them, and they get 0 for that question on the test because they don't follow directions. I do give you problems that you can do. The example we're going to do it here in a minute, yes, you can do it very easily using antiderivatives. That's not the point. Okay. Now, an aside before we continue. AP will have you solve problems using the trapezoid rule. If AP has you solve problems using the trapezoid rule, they expect you to do it using a table of values. Similar to what you had on your first quiz, only the directions will say, instead of using a Riemann sum, use the trapezoid rule. So they give you the values. You have to interpret which are your A and B for each trapezoid that you're going to do. And they're almost always don't do it equal width either. So you really kind of have to, they give you a table of values to work with. We actually create the table of values based upon the function we're giving. You do know how to do it by a function. AP, they give it to you from a table of values, and we will practice their version of it before you take the test. Oh, definitely. This is much more accurate. And there's another one. There's another hand rule to use. It's called Simpson's rule. It is in your book. I don't touch it because it's like f of x plus 2f of x plus 4f of x plus 2f of x plus 4f of x plus 2f of x. Yeah, it's a really complicated version. It is extremely more accurate than this. It's still not as accurate as doing antiderivatives. Okay, and it is. And what it is how far apart they are determines the curvature. How much curve there is will determine how accurate this is, more than anything else. Okay, but it works pretty good. This does work pretty good, close enough for anything we need. In fact, we'll do the exact one doing antiderivatives and compare. Okay, so whenever I do trapezoid rule, and this is how I work out how I have the answer key for your test, is I make a table. To me, it's easier to work using a table of values than it is to do it by hand or do it some other way. Although I have students that they just use this formula and figure out what the f of x is and plug it in here and do that. I'm good with that too. I find the table of values helps keep you organized. Okay. Yeah, like I said, anything to help keep you organized works so much better. I have a young man in one of my classes. I know the reason why he struggles getting passing grades. It's not because he's not smart. It's because his backpack is just basically a wad of papers. So he goes to pull something out, and here's just a stack of crumbled up papers, and nothing's flat, nothing's organized. It's just this mess. I'm going, okay, I know why you're not doing well in class. Yeah, it's just completely unorganized. Being organized really helps. Okay. So let's start the easy part. B minus A over 2n. What's our B? 2. What's our A? What's our N? 4, because they tell me it's 4. I tell you what it is on your homework. So 2 minus 0 over 2 times 4. 1/4. Okay. So I'm going to take what I get times 1/4. When I fill in the table and I get my total, I'm going to take my total times 1/4. Now, here's how you fill in the table. N goes from 0 to whatever n is. 0, 1, 2, 3, 4. Our corresponding x's. What is our A? What's A? 0. What's our B? 2. We have to fill in the corresponding n's to work it out. Decimals are fine for this, trust me. Yes? Yeah, my interval is from 0 to 2. 0 to 2. No. N is how many subdivisions I have. Okay. So, 0 to 2, that means 1 is halfway. 0.5, 1.5. And trust me, decimals are fine because you're going to want to do this all in your calculator. We're doing estimation anyways. You do not want to be squaring fractions and adding and subtracting fractions you squared. Right? Nobody wants to do that. Use your calculator, decimals. Okay. What is our function? X squared. So when I take f of x sub n, this is x sub 0. This is the first one. A is my first function. F of x sub 0, that's my first thing. I square it. I square this column here. So I square the first number, I get 0. I square 0.5, I get 0.25. I square 1, I get 1. 1.5 is 2.25? 15 squared is 225, 2 decimal points because they squared, right? And then 2 squared is 4. Now, so you see where I'm getting the number from the column. First one is my n. I always go 0 to whatever my n is. This is my subdivisions. This is how many rectangles I'm breaking it up into. Okay? This is where my first rectangle, this is the x value where I begin. This is the x value I break in. These are all where the lines are that I draw, where the x coordinates are for those. Yes?
So, like, how do you know those middle numbers? Are you supposed to, like, split it up?
Yeah, split it up equally.
So it's not like you don't plug it into the equation or anything?
No. Oh, this one's here? Yeah. This one here? Yeah. I start here. Let me do over here on the board. Might as well give you both sides, even though we're not doing it. What are we doing? We're going from 0 to 2. We're finding the area under here, right? How many pieces are we breaking it up into? 4. So there's one rectangle, or one base, second base, third base. 0, 1's halfway between 1 and 2, 0.5, 1.5. That's where we get them from. Because these are our lines that we're going to be doing it up.
So there's just like the x coordinates.
Yes. Those are the x coordinates from where we start to where we end.
Area.
Yeah. No, we're not finding that. We're going to get there. Okay. Our next column is 2 times this function, but we don't do 2 times all of them, do we? Which ones do we not double? First one, the last one. So I always just take the first and the last, move them over, and then double the rest. Point 1, 2, 4.5, right? So what I have here, if we go back and look at the formula, f of x sub 0, 2 times f of x sub 1, 2 times f of x sub, that's what we're doing in the table. We're doing this in that table. F of x sub 0, 2 times f of x sub 1, 2 times f of x sub 2. We're doing what's in that parentheses part. That's what this is. Each one of these are the y parts going with our curve that we have. Total it up. Add them together, total. Six, 5, 6, 7. So this is not our answer. This we just figured out that's 11. And what did we figure out this part here was? 1/4. So to find our final answer, the integral from 0 to 2 of x squared dx using the trapezoid rule is 11/4. Which is what? What's that work out to be? That's 2 3/4? 2.75. You can leave in fraction form or put it in a decimal because the rest of it was decimals. This one works out nice because these decimals here add up to a whole number, which is nice. Don't count on that. So if that doesn't happen, give me a decimal answer at the end. Okay, this one just happens to work out nice that way. Our total adds up to a perfect whole number. Don't count on that on your homework. Okay. Now, for snorts and giggles, I know you hate it. The integral from 0 to 2 of x squared dx is, what's the antiderivative of x squared? Yeah. So I take 2 cubed over 3, right? minus 0 cubed over 3, which is 0. 2 cubed is 8. So I get 8/3. 8/3 is the exact value. Now 8/3 is what? 2.6 repeated. 2.75, 2.6. Not too bad. Not too bad. If I'd broken it up into more intervals, it'd be a lot closer. A lot closer. And this demonstrates with the concavity the overestimation. X squared is concave up. The second derivative is positive, so it's concave up. So it's an overestimation because when I connect these dots, now I'm doing it here. The curves underneath the top of the line. If you have something that's concave up, you have your trapezoid like this, your curve goes underneath it if it's concave up. Like I said, I'm over exaggerating here, but that's why we have an overestimation with our trapezoid. Okay, if it's concave up, the second derivative is positive, it's an overestimation. If your second derivative is negative, it's concave down, you'll have an underestimation because the lines connecting your f of x's will always be under. And so your trapezoid top will be under the curve. There's actually a formula in your book, and I've used it before, to estimate what your error will be, how accurate you're going to be, and it doesn't take much more of an iteration to get extremely accurate. If I double n, I'm going to be almost dead on. I'll be within about 1,000 if I double n on this one. Okay, so it doesn't take much to do it. It doesn't take much to get my accuracy. And there's a formula for it. It's a complex formula. I don't teach it anymore. You don't need to know it. It's just kind of a neat one. Your book does it if you want to check it out. But there is a good formula for the approximation. Yes.
So you say like 4 is probably like.
Yeah, and I think all your homework says 4. I think your homework is all specific, and it says believe it says n equals 4. Makes it easy. I'm going to give you n equals 4 on the test, just to make it easy. Okay.
What's your example of a function that we can't use the derivative without?
Oh, I can give you one of those, but I'm going to pop.